I think you've really set the scene for us to hear from two steelmakers. First up, Greta Stephens, Chief Executive Climate Change at BlueScope. Greta, can I hand over to you, please?
Sure, thank you very much. And thanks so much, Hayley, for that introduction. It really does set the scene very well. So, tēnā koutou katoa from Aotearoa, New Zealand. I'll begin by acknowledging the tangata whenua of the land from which I'm joining, which is Ngāti Tiata, and I pay my respects to their elders past and present. So today I'd like to give you an overview of BlueScope's decarbonisation pathway and the key enablers that will help us deliver that pathway, although I think Hayley's covered them all for me. And a focus on the importance of collaboration as we transition to net zero. And am excited to share some of the pilot projects that we've recently announced. This is my first opportunity to engage in a forum like this with MECLA since I've been appointed to the role of Chief Executive Climate Change at BlueScope. So I'm looking forward to the discussion we'll have today, and I'm sure many into the future. So brief overview of BlueScope and the steel sector. We are a steel products building company focused on the Asia Pacific region. We have 14,000 people across 17 countries manufacturing a wide range of branded steel products. The steelworks at Port Kembla in the Illawarra is the largest steel production facility in Australia with an annual capacity of about 3 million tonnes. We are also the only integrated steelmaker in New Zealand, where I am today, and we have a steelmaking facility in Delta, Ohio in the US. So all up, we make about 6 million tonnes of primary steel a year. So 6 million tonnes. Globally, the market is 1.8 billion tonnes produced in 2020. And according to the International Energy Agency, the global demand for steel is projected to increase by more than a third through to 2050. And you'll hear different numbers on that projection, and they really depend on the scenario that you're thinking about. Just to pick up on a thread from what Hayley was talking about, if we talk about ultra low emissions or net zero emissions green steel, out of 1.8 billion, there's about 100,000 tonnes made a year, and that's essentially the output of existing pilot plants. So while we are a really small steelmaker in global terms, we have a big footprint and an important role in our local communities and their economies, as well as in the domestic steel supply chains, particularly in Australia and New Zealand. As Hayley's mentioned, steel is really important to the circular economy and is an enabler for underpinning our transition to renewable energy going forward, being used to build wind towers, solar farms, and transmission infrastructure. Increasingly, our products are being developed to help support the achievement of more sustainable outcomes. So there are some examples of energy efficiency and climate resilience. So we're talking about cool roof solutions, which have low levels of solar absorbance, advanced coating technologies, which are more durable and resilient to the Australian climate, and things such as ultra-high strength steels, which means we can use less steel overall for lower levels of upfront carbon. We're very committed to developing responsible products and supply chains, and product transparency, including transparency on embodied emissions, is central to this. So we were the first Australian company under the EPD Australasia program to publish environmental product declarations. We're a founding member of Responsible Steel, which is the industry's first multi-stakeholder standards and certification initiative for responsible sourcing and production of steel. And achieving greenhouse gas reductions in line with the Paris Agreement is key to responsible steel site certification, which we are currently undergoing at our Port Kembla Steelworks. So action on climate change is one of the things that matters most to our stakeholders, including our customers, and that is why it's completely integrated to our corporate strategy and our capital allocation framework. We strongly believe that reducing our emissions is not only the right thing to do, it completely aligns with our BlueScope purpose, which is to strengthen our communities for the future. So in mid-August, BlueScope announced a goal of net zero greenhouse gas emissions for Scope 1 and 2 by 2050, as well as a new medium-term 2030 target for our midstream production. And that's in addition to the target we already had, 2030 target for steelmaking emissions intensity reduction. So in absolute terms, from 2005 to 2030, these targets represent emissions reductions of 35% across our global steelmaking operations and over 45% in our Australian business. So as Hayley's already presented, there is no escaping that steelmaking is a really significant source of global greenhouse emissions, accounting for around 8% globally. And the challenge we face is a technology gap between our current high emissions processes that use coal or fossil fuels as the reductant and our future state, which will be low or zero emissions processes. And so this is the first area where we need widespread collaboration, because bridging this technology gap is bigger than just our company and even our sector. We need to work with others to achieve it. So if we delve a bit deeper into the technology gap, let's start with what zero emissions iron and steel making could look like by, say, the 2040s, mid-2040s, based on current projected scenarios, and work backwards. So most forecasters believe that hydrogen-based iron making processes will play an important role, and along with that increasing proportion of secondary steel making, recycling scrap through EAFs, and both of these based on 100% renewable energy. It is important to be aware that neither the iron making technology nor the economics of hydrogen are there yet. Even if hydrogen-based iron making technology were ready today, the cost of input hydrogen is not yet even close to where it needs to be. The cost of hydrogen will be a function of its manufacturing cost and the cost of input electricity. The manufacturing cost is expected to fall rapidly as electrolyser technology matures and grows in scale, leaving electricity price being the major variable in the future between regions. For hydrogen-based steel making economics to stack up, there will need to be, firstly, a hydrogen industry in Australia, and it will need to produce at less than the current aspirational $2 per kilo target. And it needs to be produced close to the point of use, because hydrogen is very expensive to store and to transport. So to achieve this, we need collaboration. We need to build out a local hydrogen supply chain, and this is going to require multiple companies across multiple sectors to be ready and able to provide those necessary offtake quantities to underpin the investment required. So as well as the economics of hydrogen, I mentioned the iron making technology isn't there yet on many fronts. Now, although the DRI process does operate commercially on natural gas in some regions, no one has yet stabilised this process on hydrogen. And in terms of raw materials, the existing DRI process favours certain types of ores over others, and the industry needs to research how we can achieve successful DRI metallisation on the Australian Pilbara ores. So on that front, I'm pleased to share with you some exciting pilot projects. So in late October, we announced we're joining forces with Rio Tinto to explore options for a pilot of low emission steel production at Port Kembla. So we will be using the Rio Tinto Pilbara iron ores with green hydrogen produced from renewable electricity in a direct reduction process to produce low emissions iron feed. And the DRI from that process will be further melted in an electrical furnace also powered with renewable electricity to produce iron suitable for input to steel making. So this collaboration is part of BlueScope's Climate Action Fund of up to 150 million over the next 5 years. And we're pretty excited as this project and others will take us to the cutting edge of current technology development to push us all to the next phase of bridging the technology gap. We're also planning a pilot hydrogen electrolyser plant at our Port Kembla Steelworks with a longer term view to developing a hydrogen hub in the region. And we're eager to see what this pilot electrolyser will be able to teach us about the production, storage and handling of hydrogen, and importantly, how it behaves in the blast furnace. The pilot is designed to be small scale. We're currently planning for 10 megawatts. Now, in fact, we could potentially use up to 300 megawatts in the blast furnace. However, as I've mentioned, that high capital and operating cost of electrolysers at this stage make a small pilot the most feasible option so we can learn and allow us to scale up when the economics of hydrogen improve. So moving on to other areas where we need collaboration, let's look at energy, particularly electricity. To move fully to low emission steelmaking, we will need a significant increase in firmed and competitively priced renewable energy. Firmed is crucial. Iron and steel making are 24/7 processes that aren't easily turned on and off. So electricity storage and grid interconnection will be essential to buffer wind and solar. To give you a sense of scale, if we switched Port Kembla across to a future low emissions iron and steel making, we would need 15 times our current electricity requirements, taking us up to 1.4 gigawatts. So that's like 1.4 times the Tomago aluminium smelter, for example. So electrifying these processes requires an enormous build out of renewable energy. Planning and investing in the infrastructure that we need to support that increase in renewables will be crucial. Now we're getting on with it as far as we can. We have a 7-year PPA from the solar Finlay farm, and we take 2/3 of the electricity generated there, which equates to about 20% of our energy consumption in Australian steel products. So finally, underpinning everything else we do, we need to collaborate to develop the public policies that we needed to drive and support the transition to the low emissions iron and steel making. Policies that incentivise and underpin competitively priced, firmed, well-planned energy supply, and that will power that emergent hydrogen supply chain to enable the adoption of finally those breakthrough technologies. The policy framework also needs to include a level playing field for lower greenhouse gas emission steel, because we can't risk the investments in carbon efficiencies being undermined by imported steel that hasn't borne those costs. We know the demand for low embodied carbon materials is growing, and we're proud of that to be a founding partner of MECLA, leading this change in the built environment. As I've outlined, collaboration is key, and it's how you can support BlueScope and other steel manufacturers committed to decarbonisation and transparency. So echoing what Hayley said on the demand side of the equation, by asking for credentials such as EPDs, eco-labels, responsible steel certification. We welcome the discussion about our targets and our goal and how we're going to get there, and it will help to support us on our decarbonisation pathway. So in closing, I hope I've built on what Hayley said, shed some light on what we need to build out this industry in Australia, why collaboration isn't just important, it's essential to get our steel industry to net zero. I have a feeling that many of you working in the built environment will relate to these issues, and I'm looking forward to hearing your perspectives. So thank you.
Greta, thank you very much for that. It's, well, the word collaboration came up half a dozen times in your talk there, and that's clearly why we set up MECLA. None of this can be done on our own, and the fact that you've got a collaboration looking up your supply chain, and you're also talking now to many people down your supply chain. So it's great to hear your perspective and the positive steps you're taking, and just how long that journey is going to be. So we're in it for the long haul.